Between 1970 and 2007, the annual cost of education increased by more than twofolds, while the total student enrollment increased by more than twofolds. This is what the regular graph looks like. Y-axis and x-axis. So this would be the supply. This would be the demand. This would be the initial equilibrium. I'm gonna call it point A. Okay, so the demand shifts right because there is more students enrolling by a lot because it's more than twofolds. And the supply would shift left because there's not that much supply. That would increase the price. And I believe that's what it should look like. Not gonna lie, I'm not even sure because I'm not the brightest when it comes to economics, but I think this looks right. B. The following depicts a consumer who initially considers X and Y as independent, then complement. Graph her price consumption curve. This is what he gives us. Y and X. It looks something like this. Not gonna lie, I don't even know. When did Mr. Mazahari talk about this? It looks something like this. So, looking at the trend, it actually, something like this. I remember the price consumption curve, it goes up like this. It would look something like this, I believe. Okay. I don't have an explanation for this, but I just remember that it looks like this. C. Graph the indifferent maps for the two cases. So, case I. So, coffee, sugar. I always have my coffee with 2 sugars. So, I believe this is a perfect complement. So, let's look at coffee. So, he has 1 coffee with 2 sugars. So, the ratio is 1 to 2, and so for 2 coffees he'd have 4 sugars. So it would look something like this. It'd be a linear line, and this is what the line would look like. Okay. D. Kumar cannot live without 2 cups of coffee a day. In fact, with less than 2 cups a day, he doesn't care about food at all. Suppose that once he has 2 cups of coffee, he only cares about food. Okay. The question should pop up. That's the editing skills. Go into use. Okay. So he cannot live without 2 cups of coffee. So he needs his coffee. Coffee is on the y-axis, so let's take a look. 1 cup, that's 2 cups. 2 horizontal lines, it'd go this way. After this, he does not care about coffee, so there will be no horizontal lines. Because food is on the x-axis, to kind of show that there's no coffee needed, you use vertical lines. So that'd be something like this. I believe. I'm not a registered TA. UTSC need to sign me though. But I'm not registered, but I believe it should look like this. So the explanation is after 2 cups of coffee, there's 1 cup, that's 2 cups, he wants food. So there's no more coffee, it's just food. Okay. D. Mary's utility for water Y is given by U equals X, Y equals X plus 2Y. I'm just gonna show the question, so I don't have to say it. I can't read. I'm an English language learner. Okay. Okay, so first, we'd have to look at the marginal utility. Marginal utility of X over the price of X. So that would equal to, it's really just 1 divided by 1. So equals 1. Now we'd have to look at marginal utility of y divided by the price of y equals to, I believe that's, is that 2? Okay, yeah, it's 2 divided by 1. So that'd be equal to 2. Because this is the MUX and this is the MUY. I believe, I'm not sure. And now we know that her income is $20. So when we look at the marginal utility, we see that the marginal utility of y over py is bigger than the marginal utility of x. So that would mean that he's getting more from y, so he would only consume y, no x. So the graph would look like something like this. So he has 20, so that'd be 20 here and 20 down there. And then there'd be a tangent line right here. I believe that's how you do D. Next question. Hold up, no, this is D. I don't know what question. Okay, this is D as well. So the question should pop up on the screen. So Adam likes, okay, so what are some key things? The coffee costs, so price of a coffee equals to $1. And the price of a donut equals to $1. He receives a coupon. And after he purchases 5 cups of coffee, so he gets 1 free cup, and then he gets a 50% reduction. So after that, the price of X would be equal to 0.5. Okay, and then income, he has $10 to spend. Okay. So top would be donut, the bottom would be coffee. Okay, so looking at 10, we first make the original. That'd be, oh, that's completely off, but you get the idea. Right, that's 10, 10. So at the point where he gets 5, so that'd be here, he gets 1 free. So that should be right here, 5. He gets 1 free cup. So that'd be right here. That's the free cup. And then after, the cups cost 0.5. So 10 minus 5 equals to 5. So he has 5, and then multiply by 0.2. That'll give you 10 more cups. So you have 5 cups plus 1 free cup plus 10 cups. So that'll give you 16 cups. So right here, this would be approximately 16, and I believe that's how the graph should look. Something like this. It's probably more spaced out. I'm a terrible drawer though. So that should be how to do D. Okay. Okay. Now for question E. A consumer had actually, nah, I'm gonna just put the question up. Okay, so I equals to $100. The price of X equals to 10. the price of y equals to 5. The utility equals to 0.25, y 0.25. Okay. Okay, so given the original, he purchased 5 of x and 10 of y. But with the new increase, inflation, the price of x equals to 20, and people only purchase 2.5. Hold up, the price is still 5. Okay. Damn, okay, this is a substitution effect. Okay, I'm gonna take a water break and then I'm gonna come back. I don't know how to edit, so there's not gonna be any cuts, unfortunately. Okay. Damn, okay, so first we're gonna look at this one where x equals to 5 and y equals to 10. So given the utility function, you plug in what x equals, 0.25, and what y equals to 10, 0.25. That will give you, hold up, put that in the calculator, and you should get 2.6519. And then you do the budget line, I believe that's what it's called. 10x plus 5y, and that will equal to I, which equals to 100. So that's the same thing as this, px plus py equals to I. Okay. Okay, then you look at the new equation. With 10x plus 5y equals to 100, keep that there. What is the marginal MRS? I don't even know what it stands for. I don't believe Mr. Mazahari went through this one. So that would be MUX divided by MUY, which is also equals to y divided by x, which equals to PX divided by PY. And we know that to be 20 divided by 5, which equals to 4. Okay, so using that, we know y divided by x equals to 4, which means y equals to 4x. Okay, so now we know this. We want to put that into this equation right here. So 10x plus 4x equals to 100. That would mean that 30x equals to 100, which would mean that x equals to 100 divided by 30. Is that 10 divided by 3? Okay, yeah, something like this. Okay. And then we look at this, we have to find x at MRS equals to 4 and the utility where ut equals to 2.6519. Okay, so using that formula, we know x.25, y.25 equals utility 2.6519. So we can put in what we know from before, y equals to 4x. It's 0.25. 4x 0.25 equals to 2.6519. I'm not gonna lie, I forgot how to use a calculator. So I switched this up and it should be equal to 3.536. Okay. And that's how that's the distance in between. 2.5, 3.536, and then 5. So what do I mean by that? I don't even know, to be honest. I figured this out last night. It took me like an hour. Clearly, I'm not the brightest, unfortunately. So, substitution effect. We see that x equals to 5. And we see that x equals to 3.536. To be honest, I don't think it matters which way it goes. As long as it equals to x equals to 5, x equals to 2.5. The distance in between is 2.5. So I'm going to do 5 minus 3.536. That's the substitution effect. Let me use my calculator real quick. That will be equal to 1.464. The income effect, that would be equal to 3.536 minus 2.5, which is the x over here. That would be equal to 1.036, and they both add up to 2.5, which is the distance in between 5 and 2.5. Okay, what does this look like on a graph? Okay. So we know that the total would be 20 and I believe 10. Okay. So yeah, px over here and right here. Oh wait, no. And yeah, something like this. Okay. And then at 10, x equals to 5. That'd be somewhere like this. Okay. And then at 2.5, y would be equal to 10 again. Okay, so this is the total effect. And then in between, right here, 3.536. This would be the substitution effect, and this would be the income effect. Okay. And then, honestly, this is how I learned to do it. I don't know why they're drawing all types of tangent lines and stuff, but I guess I could try. So, have a line from 20 to 5, and that'd be where, I forgot, what is this called again? A curve, a tangent line. And then this, there have to be a line that would be synonymous to this. I don't even think that's a word, to be honest. I heard it in a commercial. It'd be parallel to this line. And because it's parallel to this line, that's how we use the MRS formula, where we made it equal to 2.6519, because if they have the same, I think, line, then that means they have the same utility. And I guess that's how you do it. Honestly, I'm still learning. I'm pretty bad at this subject, to be honest. But that's question 1. I'm gonna take a look at question 2 real quick. Okay, so this is dealing with price elasticity. Okay. So first, we know the formula of ED equals to price of demand divided by quantity demand, and then multiplied by the change in quantity demanded, change in, price demanded. So clearly says that elasticity of demand is -0.6, and the price, I'll just write it here. Price equals to 200 and the quantity equals to 100. Okay, so that'd be 200 divided by 100. So that'd be equal to 2 multiplied by whatever this is. Okay. So quantity demand change, the change is equal to 0.3. Okay. And then you know that this is the general formula equals to x. That's the unknown minus 0.3 price demanded. So the quantity demanded, that's just 100, equals to x minus 0.3, 200. So 100 equals to x minus 60. Okay. And then x equals to 160. So the final formula, we plug it back in without the quantity and price. It'd be 160 minus 0.3 PD. Now the same thing for elasticity of supply. That'd be equal to price, was it price supplied? Is that what it's called? Man, it don't matter. I'm just gonna do the same thing. Equals to 200 divided by 100 and then multiply by the change in quantity supplied or whatever this is. So that would be equal to, so the price elasticity is 2, so 2 multiplied by this. So that would be equal to 1. Okay. And then the formula for the supply is equal to, I believe, x plus, what was it, 2 PS. Oh wait, no, it's 1 because this equals to 1. Okay. So 100 equals to x plus 200. X equals to negative 100. Okay. And then look at the formula. It should be quantity supplied equals to negative 100 plus P. Okay. Question B. In order to promote bicycle riding, the local government has started paying $20 subsidy. What does this mean? I remember in class he said it'd be some like price. It actually decreased the cost of making the bicycle. So it would be something like this. Okay. Whenever there's a subsidy, you have to put everything into the inverse. So you'd have to make the top price. So for this, for the quantity demanded from before this, it would be equal to PD equals to 160 divided by 0.3 minus Q divided by 0.3. And then for price supplied, it'd be equal to, it'd just be equal to minus 100, and then, so this would go here. Hold up. It'd be equal to P equals to QS plus 100. Okay. Now we have both formulas. So this price demanded, this is price supplied. We put it in, 160 divided by 0.3 minus Q divided by 0.3 equals to 100 plus QS minus 20. The minus 20 comes from the subsidy. I don't know how to use a calculator, so I'm just gonna write what the answer was. I searched this up last night. It'd be 104.62, and the price would be 184.62. And that's the answer.